Hello and welcome to Chapter 2, Modulation AM Part 3. So before this, we have discussed about the different type of suppressed signal, okay? So the first one we have learned before is double sideband suppressed carrier, DSBSC. It is generated by a circuit called balance modulator, where it is produce sum of FUSB and the difference FLSB frequency, but cancel or balance out the carrier frequency. What it means is the carrier here, FC, is no longer there. So it helps by reducing power, but the bandwidth is still the same as DSBFC, okay, double sideband frequency carrier. It is still the same, okay. But here we have removed the FC. There is no frequency carrier here. So this is what the signal should look like if the FC is removed or suppressed in a way where this is a full carrier AM signal, while this is a suppressed carrier. Looks more smooth over here. Okay, this is the difference between these two signals. So from for AM DSBSC, from the full AM equation, this is the full equation. If you still remember, it includes the carrier, the lower sideband, and the upper sideband. This is the full equation. But when we remove the carrier signal, the equation will become like this. You will only remove the EC sine omega CT, and we will be left with these two equations for lower sideband and upper sideband. Okay, so when FC is removed, the PT should also be only PLSB plus PUSB, which results in the equation for E squared over 4R. So all the power here is transmitted into the sideband only. So the power is not wasted on FC because FC is removed. So this is a single sideband modulation. We already remove either one of the upper sideband or the lower sideband, leaving with one only. So with single sideband suppressed carrier or SSBSC, the carrier and one of the sideband is suppressed, and all of the power is channeled into a single sideband. It's either the lower sideband or the upper sideband, depending on which one you remove, and it will produce a stronger signal. The bandwidth will be narrow because the either of the sideband is removed, and the noise is reduced. But by doing this, sure, it produces a stronger signal and the noise is reduced. But it is difficult when you want to demodulate at the receiver because the signal is missing the frequency carrier and either of the sidebands. Okay, with that, a low power pilot carrier is sometimes transmitted along with the sideband to help demodulate process at the receiver. So add a single sideband suppressed carrier equation. As you can see, this is a full AM equation, still the same thing as the above one over here, but now we are removing either the upper sideband. Okay, remove the carrier and one of the sideband of the equation becomes, when upper sideband is removed, the equation will become like this, where it is the omega C minus omega M. This is the difference here for both lower sideband and upper sideband, where if the lower sideband is removed, it will become M, modulation index, voltage divided by 2 cos WA omega C plus omega M. Okay, as you can see from both of these equations, the differences is omega C in the minus the omega M and omega C plus omega M. That is the difference in LSB and USB for single sideband suppressed carrier equation. Okay, what are the differences between these two in a time domain? Okay, in time domain, single sideband signals, this is for lower sideband. Okay, AM, single sideband, lower sideband. The frequency between all of this signal is more wider, while the upper sideband, if you use the upper sideband time domain, the frequency is narrower. Okay, it is more narrow in upper sideband. Okay, this is for frequency domain in single sidebands, where, as you can see, this is the omega m over here. Both are the same for modulating band, but with upper sideband over here, it is more further from Wm. Okay, this is the omega c plus omega m, and for the lower sideband, omega c minus omega m, it is before omega c over here. For upper sideband, omega c plus omega m should be higher than omega c over here. Okay. Alright, that is the simplest way to show the differences in USB and LSB by using these two different diagrams. Okay. Alright, what is demodulation? It is only the opposite for modulation, where in modulation you are using a carrier signal with modulating signal to change the signal so that it would be able to transfer using transmitter, and then in the receiver side, okay, you will change back the signal into the original signal. That is what demodulation does. So it is also called detection, and it is a reverse process of modulation. Okay, so two most used AM demodulator is diode detector circuit and product detector circuit. Okay, that is the two most used demodulator. Alright, what is an envelope detector? So an envelope detector is an electronic circuit that takes relatively high frequency, amplitude modulated signal as input and provides an input which is the envelope of the original signal. So it can be used to demodulate as a previously modulated signal by removing all high frequency components of the signals. And the capacitor and resistor form a low-pass filter to filter out the carrier frequency. So it is used to demodulate AM radio signal because the envelope of the modulated signal is equivalent to the baseband signal. This is how the circuit would look like for diode detector circuit. Includes a diode, a capacitor, and a resistor over here to create a filter. Okay. So this is the simplest form of envelope detector, and is the diode detector, okay, which is shown above. It is a diode between the input and the output of a circuit connected to a resistor and a capacitor in parallel from the output of the circuit to the ground. If the resistor and capacitor are correctly chosen, the output of this circuit should approximately voltage shifted version of the original baseband signal. So the capacitor in the circuit stores charges on the rising edge and releases it slowly through the resistor when the input signal amplitude falls. The diode in series rectifies the incoming signal, allowing current flow only when the positive input terminal is at a higher potential than the negative input terminal. So both of these you can read by yourself here for product detector. It is just the theory for product detector. Okay, so that is all for AM modulation. We will see you again with the frequency modulation. Thank you for watching.